receptors. I discussed about the property of specificity. Right? Now the second property of sensory receptors is receptor potential or generator potential. Receptor potential or generator potential. When a stimulus is applied to the receptors, when a stimulus is applied to the receptors, there is a localized change. There is a localized change in the membrane potential. And that localized change in the membrane potential is due to sodium influx. Is due to sodium influx. This receptor potential, it resembles EPP, end plate potential, or EPSP, that is excitatory postsynaptic membrane potential. Excitatory postsynaptic membrane potential. What is the purpose of receptor potential? Its purpose is to bring the membrane potential, from the resting value to the threshold of excitation. From the resting value to the threshold of excitation. Once the membrane potential reaches the threshold, then there will be discharge of impulses from the receptor along its nerve fiber, along its sensory nerve fiber. So the purpose of the receptor potential is to bring the membrane potential from its resting value to the threshold of excitation. Resting potential is about say minus 85 or minus 85, 80 millivolt, and threshold is about say minus 65 millivolt. So to bring it from the resting value of minus 85 to threshold of minus 65, there is receptor potential, which is called generator potential. This receptor potential is due to sodium influx. Sodium influx. We know different types of stimuli: electrical, mechanical, thermal, chemical. So as a result of these stimuli, there is opening or activation of sodium channel. There is opening or activation of sodium channel. So when there is activation of sodium channels, there is sodium influx. Sodium influx inside of the membrane becomes less negative to reach the threshold of excitation. And this is the receptor potential or the generator potential. Frequency of discharge of impulses. Frequency of discharge of impulses depends upon the amplitude or voltage of the receptor potential. Frequency of discharge of impulses depends upon the amplitude of the receptor potential. Greater the amplitude of the receptor potential, greater will be the frequency of discharge of impulses from the receptors along its sensory nerve ending. So greater will be the voltage of receptor potential, greater amplitude, greater will be the frequency of discharge of impulses along the sensory nerve fiber. Of course, the amplitude or voltage of receptor potential depends upon the intensity of stimulus. The voltage or amplitude of receptor potential, it depends upon the intensity of stimulus. I can say, stronger the stimulus, more will be the amplitude or voltage of the membrane potential. More will be the voltage or amplitude of the receptor potential. So greater will be the discharge of impulses from the receptor along its nerve fiber. So greater will be the frequency of discharge of impulses along nerve fiber. I repeat, stronger the stimulus, more will be the amplitude of voltage of the membrane potential, and greater will be the frequency of discharge of impulses from the receptor along with sensory nerve fiber. So this was about the receptor potential or the generator potential, its value. Our next property of sensory receptors is very important, that is adaptation. Adaptation. While discussing the sensory receptors, I mentioned there some of the receptors undergo slow adaptation. Other receptors undergo rapid adaptation. Some undergo slow adaptation, other undergo rapid adaptation. So what is adaptation? Adaptation. When a stimulus of constant intensity, is applied continuously to the receptors. So when a stimulus of constant intensity is applied to the receptors continuously, after some time, discharge of impulses from the receptor along its sensory nerve fiber decreases. So after some time, discharge of impulses from the receptor along its sensory nerve fiber decreases. I again repeat that when a stimulus of constant intensity is applied continuously to the receptors, after some time, discharge of impulses from the receptors along its sensory nerve fibers decreases. This is called adaptation. Adaptation. Depending upon the degree of adaptation and its rate of adaptation, there are two types of receptors. Phasic and tonic. Phasic and tonic. Phasic receptors, also called rate receptors, movement receptors, rate R-A-T-E, rate receptors or movement receptors, these undergo rapid adaptation. So phasic receptors, also called rate receptors, these undergo rapid adaptation. One other type of receptors is tonic receptors. Tonic receptors undergo slow and incomplete adaptation. Tonic receptors undergo slow and incomplete adaptation. Phasic receptors, which undergo rapid adaptation. These include the touch receptors. Touch receptors undergo rapid adaptation. These are the phasic receptors. What are the tonic receptors which undergo slow and incomplete adaptation? These include pain receptors, cold receptors, baroreceptors in the carotid sinus arch of the aorta, baroreceptors, muscle spindles, right? So pain receptors, cold receptors, aortic and carotid baroreceptors, muscle spindles, these undergo slow and incomplete adaptation. You see in this figure, these receptors, you see, these include hair follicle receptors and the Syngian corpuscles. so hair follicle receptor and precinial corpuscles, these undergo rapid adaptation. These undergo rapid adaptation. You see, in 1 second, their response or impulses per second from these receptors will decrease. So these undergo rapid adaptation. These include the hair follicle receptors and precinial corpuscles. What about these receptors? Joint capsule receptors, say roughened end organs, muscle spindles, roughened end organ, muscle spindle. These undergo slow and incomplete adaptation. You see, you appreciate, these undergo slow and incomplete adaptation. So these are not adapted fully. Even after 8 seconds, these are not adapted. So these undergo slow and incomplete adaptation. So these are the phasic receptors, including hair follicle receptors and precinial corpus. And these are the tonic receptors undergoing incompletely slow adaptation. And these include the joint capsule receptors, say roughened end organs, and also the muscle spindles. Keep in mind that adaptation of receptors, rapid or slow, both are physiologically important. So sensory adaptation, both rapid and slow, phasic and tonic, both have got physiological importance. First, about the rapid adaptation. What is the significance of rapid adaptation? So because of the rapid adaptation, we can perceive new stimuli, and we can also perceive change in the intensity of stimuli. So we can perceive new stimuli and change in the intensity of stimuli. For example, in the morning, we take bath, and we wear clothes. After a short period, touch receptors in the skin of the body adapt to the clothes. So after some time, you don't feel the clothes presence. Say, an insect crawls over the skin. Under the clothes. We are able to perceive the movement of the insect under the clothes. We can perceive the movement of the object, the insect under the clothes. Why? Because the touch receptors have adapted to the clothes. And the new stimulus, the movement of the insect, we are able to perceive. Right? So if one insect crawls off the skin under the clothes and sits there without biting, the second insect crawls over the skin. The second insect will crawl over the skin. We can also feel the crawling of the second insect. We can also perceive the crawling of the second insect because we have adapted to the first one. So it shows that due to rapid adaptation of sensory receptors, new events can be perceived. And this is because of the rapid adaptation of the receptors, the phasic receptors, which which are touch receptors, we are able to perceive the new events. What about the significance of the tonic receptors or slow and incomplete adaptation? Significance of the slow and incomplete adaptation. Say, pain receptors undergo slow and incomplete adaptation. Pain receptors undergo slow and incomplete adaptation. Pain is a protective sensation. Pain is a protective sensation. It is a warning sensation. It is a warning sensation. Say, a young boy has appendicitis. A young boy has got appendicitis. He feels pain. And this pain compels the boy to consult a doctor. So the doctor gives the treatment. And here, important point is that this pain sensation has got a protective aspect. As long as appendicitis is there, pain is felt. Because there is no adaptation, a very slow and incomplete adaptation of the pain receptors. So as long as the disease is there, this appendicitis is there, the boy will feel pain and he is able to seek the treatment. So this is the slow and incomplete adaptation of the pain receptors, that because of the incomplete, slow adaptation, as long as the disease is there, the boy will feel pain and he will seek the treatment from the doctor. Aortic and carotid baroreceptors, in how much time these baroreceptors undergo adaptation? In 24 to 48 hours. In 24 to 48 hours, the baroreceptors undergo adaptation. Now, if these receptors undergo rapid adaptation, say within a second these undergo adaptation, so would these be able to regulate the blood pressure? Would these be able to regulate the blood pressure? No. So because of the slow adaptation of the baroreceptors in 24 to 48 hours, these are able to regulate the blood pressure. Similarly, muscle spindles are involved in the postural maintenance. Muscle spindles are involved in the posture maintenance because these undergo very slow adaptation. So muscle spindles are able to maintain the posture because these undergo very slow adaptation. So this is about the significance of adaptation, rapid as well as slow adaptation. Both are physiologically important. But what is the mechanism of adaptation? I am discussing about the mechanism of adaptation of the receptors. Let us say a Pacinian corpuscle. A Pacinian corpuscle. Now we apply a stimulus, say pressure stimulus, to the Pacinian corpuscle. Now when we apply a stimulus, pressure stimulus, there is indentation of the membrane of the Pacinian corpuscle. Indentation of the membrane of Pacinian corpuscle. Indentation. Invagination. This will increase the pressure inside the corpuscle. It will increase the pressure inside the corpuscle. So along its nerve endings, along its nerve fiber, the impulse will be generated. Why? Because of increase in the pressure when there is indentation of its membrane because of the pressure stimulus. But keep in mind, after some time, this pressure inside the corpuscle becomes uniformly distributed. After some time, the pressure inside the corpuscle becomes uniformly distributed. When it becomes uniformly distributed, then discharge of impulses from the receptor, the Pacinian corpuscle, will decrease. And this is called the adaptation. So we apply the pressure stimulus to the surface of the Pacinian corpuscle. There is indentation of its membrane. Below this indentation, pressure will increase, and this will cause increased discharge of impulses along sensory nerve ending. But after some time, the pressure inside the corpuscle becomes uniformly distributed. After some time, the pressure inside the corpuscle becomes uniformly distributed. So discharge of impulse from the Pacinian corpuscle along sensory nerve fiber will decrease. And this is called adaptation. So this is the structural mechanism of the adaptation. Structural mechanism of the adaptation. The second mechanism of adaptation is that because of the continuous application of the stimulus, there is inactivation of sodium channels in the membrane of the nerve ending. So because of the continuous application of the stimulus, there is inactivation of sodium channels in the membrane of the nerve ending, and this results into adaptation, and this is called accommodation. It is called accommodation. What is accommodation? Inactivation of sodium channels in the membrane of nerve ending when we apply a stimulus continuously. This is called accommodation, right? So this is the mechanism of the accommodation of the sensory receptors. Our next property of sensory receptors is intensity discrimination. Brain is able to discriminate. Intensity of stimulus by receiving two types of signals from the receptors. So brain is able to perceive, discriminate intensity of stimulus by receiving two types of signals, impulses from the receptors. Number one, number of receptors stimulated. Number of receptors stimulated. It means with greater intensity of stimulus, more number of receptors are stimulated. So with greater intensity of stimulus, more number of receptors are stimulated. And then with greater intensity of stimulus, with stronger stimuli, there will be greater voltage or amplitude of the receptor potential. So there will be greater frequency of discharge of impulses from the receptors. So with stronger stimulus, greater will be the amplitude of voltage of the receptor potential. So greater will be the frequency of discharge of impulses from the receptors. So with stronger stimuli, brain receives impulses from more number of receptors, and there will be increased frequency of discharge of impulses from the receptors. This was about the intensity discrimination by the brain. Next property of sensory receptors, or this aspect, is sensory unit. Sensory unit. What is sensory unit? Sensory unit is a single sensory nerve fiber. A single sensory nerve fiber along with its peripheral branches. A single sensory nerve fiber along with its peripheral branches. So single sensory nerve fiber along with its peripheral branch. Receptive field. Receptive field of a sensory unit is the area from which sensory impulses are carried by a single sensory unit, a single sensory nerve fiber. So receptive field of a sensory unit is the area from which impulses are carried by the single sensory nerve fiber. This is the receptive field of a sensory unit. Now in the cornea and sclera, the receptive field of the sensory unit is 50 to 200 square centimeter, square millimeter. So in the sclera and cornea, the receptive field, the sensory unit is 50 to 200 square millimeter. 50 to 200 square millimeter. Keep in mind there is overlapping. There is overlapping of the adjacent sensory units. There is overlapping of the adjacent sensory unit. Right? So I complete discussion on the properties of the sensory receptors. I discussed about specificity property, then receptor or generator potential, and then very important property of adaptation of the sensory receptor. So which receptors undergo rapid adaptation? Hair follicle receptors, Meesner's corpuscles, the Simian corpuscles. These undergo rapid adaptation. which undergo slow adaptation, free nerve endings, Merkel discs, Ruffini's end organs, muscle spindles, right? So these undergo slow, pain receptor, these undergo slow and incomplete adaptation. I discussed the property of the receptor potential, and about the intensity discrimination, and then about the sensory unit. This complete discussion on the properties of the sensory receptor.